All right, guys, we are going to work on naming compounds and writing formulas. So, important vocabulary. A binary compound is a compound that's composed of two elements. We're only really going to work pretty much on binary compounds in here. There will be a couple polyatomic ions, which we'll go into next slide, that we will talk about, but the majority of the larger compounds we won't really touch on and how to name and how to write or anything in here. An oxidation number, so you've probably heard this word before. It's either a positive or a negative number on the periodic table, and it tells you how many electrons the element can gain, lose, or share when bonding with another atom. And we talked about that, right? We talked about the different rows and if it's easier to gain 2 or lose 6, and that indicates, or that's what tells us that oxidation number. So we're going to practice with that today. The other new term that you may not have heard before is polyatomic ion, a positively or negatively charged covalently bonded group of ions. So sometimes ionic compounds occur with these things called polyatomic ions. They're ions when they have already bonded together, and that means they're good for making ionic compounds with other atoms. The prefix poly means many, so the term polyatomic means having many atoms. And its ion is a charged thing, so it's a charged compound that has many atoms in it. And we'll talk about how to use those in a second. You can't really see this. Hold on, let me fix that really quick. Let's try again. All right. So when writing formulas, okay, so writing formulas is the first thing we're going to talk about. You're going to write the symbol of the element or polyatomic ion that has a positive oxidation number, so that has a positive charge. So you're going to look at the two atoms you've been given, and you're going to say, okay, which one has a positive charge? And that's the one that gets written first. Hydrogen is an example of a positive ion. Ammonium ion, now this is one of the polyatomic ions. It's one of the multiple atoms in a single ion, and it has a positive charge. And all metals are going to have positive charges. So hydrogen, all metals, and the ammonium ion will go first when writing these. Now, you're going to write the symbol of the element of the polyatomic ion with the negative oxidation number. So basically, you're going to write this element, or this should say or polyatomic ion. Write the symbol of the element or polyatomic ion with the negative oxidation number. So first we worked with the positive oxidation numbers, the ones that are positive, the metals and ammonia and hydrogen. Now we're going to work with the negative oxidation numbers, and those are usually the nonmetals and all other polyatomic ions other than the ammonia, the NH4+. So how you do it is you write it down, you figure out what its oxidation number is. Okay, and then we're going to play a game of crisscross. So we're going to add subscripts so that the sum of the oxidation numbers of all atoms in the formula is 0. We're going to use the crisscross method to do that. So if that first definition kind of sounded confusing, just trust me that this is how you do it. Okay, you're going to get the charge without the sign of the one ion, and it becomes a subscript of the other ion. So in other words, lithium has an oxidation number of +1, or a charge of +1. Oxygen has a oxidation number of -2, okay, or a charge of -2. Now, if these two are going to bond together, I write my positive one first, lithium, then I write my negative one. Now, to figure out what their subscripts will be, I'm just going to crisscross. So the oxidation number of this guy is going to become the subscript of the other guy. The oxidation number of this guy is going to become the subscript of this guy. Now pay attention because this is 1+, and remember, we don't write 1s as subscripts. So you'll notice that this oxygen doesn't have a subscript. Here's another example. Aluminum has a 3+ oxidation number or charge. Oxygen has a 2- oxidation number or charge. And once again, we are going to write the positive first. So aluminum gets written first, then oxygen gets written, and then we crisscross. The oxygen will now get the 3 that was the oxidation number. It now becomes a subscript for oxygen. And oxygen is going to give its 2 to aluminum, and that now becomes the subscript for aluminum. And that is really all there is to writing formulas. So we're going to practice really quick. We've got a couple of atoms here: cesium sulfide, beryllium carbide, hydrogen iodide, and aluminum oxide. So cesium is +1, sulfur is -2. We will crisscross, and we will get CS2, because the 2 from the sulfur ends up down, and the 1 down here. Beryllium carbide, crisscross. Now this one's tricky because now we're going to end up with B4C2, but we always use it in least terms, just like in math. So you're going to do, since 2 goes into both, I'm going to take 2 out of both, and we're going to get Be2C. Hydrogen iodide. H is +1, I is -1, so we crisscross and we just get HI. Aluminum oxide, and we just looked at this one. There we go. So now naming compounds, So you're going to write the name of the first element. Okay, write the name of the first element. Note subscripts do not become a part of the name for ionic compounds. So those subscripts aren't going to be in play when we're doing ionic compounds. You're just going to write the name of the substances. For covalent compounds, though, we're going to use prefixes. Okay, and the prefixes we'll look at in a sec, but they're going to indicate how many atoms of each element are indicated in the binary compound. Oops. Then you're going to write the root of the name of the second compound. So chlorine becomes chlor, oxygen becomes ox, bromine becomes brome, and then you're just going to add "ide" to the end. So an example of that would be barium fluoride. We just said the first name and then added fluoride. Aluminum chloride, okay? Wrote the first one out and then the second one, aluminum chloride. Sodium, and then we know this from our polyatomic ions, it's chlorate, so sodium chlorate. Now covalent ones use the prefixes. So covalent ones use the prefixes, and the prefixes, okay, are listed right here. So for this one that has 2 nitrogens and 1 oxygen, it becomes dinitrogen, because we have 2 nitrogens, monoxide, because we only have 1 oxygen. Now for the first letter, if there is no, if there's not multiple, if there's only one of that first atom, you don't need to write monocarbon monoxide. Okay, you don't need to do that. You can just leave it as carbon. Scientists take that as meaning 1. So carbon, but always on the second one, if there's only one, you write monoxide or mono. You use that prefix mono. This is N3F, so trinitrogen fluoride. So here's some examples, okay, of some ionic compounds we're going to practice naming. First, we've got Na and Cl. It is an ionic compound, so we just write the name of the first one, and then we write the root of the second one, which is chlor, and then add ide, so sodium chloride. We write the name of the first one, which is magnesium, and then we write the second one, root, fluor, and then ide, so magnesium fluoride. And remember, for ionic compounds, we don't use prefixes. Prefixes are only for covalent compounds. Here we have potassium, which we'll write first, and then we know this is a polyatomic ion called hydroxide, so we are going to call it potassium hydroxide. Here we have NH2, which is our ammonia, okay, and then we have our I here, so ammonium and then iodide, ammonium iodide. Here we have our calcium and we have our phosphate, so we're going to write calcium first and then phosphate. That's all for ionic compounds. Now the covalent compounds, here's where we use the prefixes. So here we only have 1 carbon. Remember, if it's the first atom in there, we don't add a prefix, so it's going to be carbon. And then we only have 1 oxygen, so it's going to be carbon monoxide. Here we have 2 nitrogens, so we're going to use the prefix di because it means 2. So dinitrogen, and then we use the prefix for 1, which is mono, and then oxide. So dinitrogen monoxide. Then we use, again, we only have one iodine here, so it will be iodine, and then look, there's a subscript here, so there's 3 chlorines. So tri is the prefix for 3, and then chloride, so iodine trichloride. We have arsenic here and oxygen here. We have 2 arsenics, so it's going to be diarsenic, and then the prefix for 5 is penta, pentaoxide. Diarsenic pentaoxide. And then finally we have phosphorus. There's only 1 phosphorus, so we'll just write phosphorus. And then the number here is trichloride. Phosphorus trichloride. All right, that is all for that. I do want to go back because I realized as we were going through this that I didn't give you any examples with the polyatomic ions. So I wanted to give you one really quick. We're just going to use, let's see, we'll use nitrate, which is -1 in charge. Okay, we're going to say calcium, no, sorry, yeah. Sorry, I'm trying to figure out, okay, nitrogen carbonate. I don't like that either. Yeah, we're going to use calcium. Hello. Calcium carbonate. And so we're going to first find that calcium, okay, calcium's charge, I believe, is +2. Okay, it's +2. Oops. Calcium is +2. And carbonate, okay, as we can see in our polyatomic ion list, is CO3, CO3 with a -2 charge. Okay, so we're going to write that. Okay, and now we can see that that is going to, we're going to crisscross just like we do here. Okay, crisscross. And that means the 2 will go down here, the 2 will go down here, and we are going to end up with Ca. Now 2 and 2, that's equal, so we don't actually need to add any subscripts, any additional subscripts. So that would be it. Okay, let's try one more just for the sake of really understanding this thing. Okay. And we are going to do sodium. We'll do sodium phosphate. No, magnesium phosphate is what we're going to do. Okay, magnesium phosphate. All right, so magnesium is Mg. You know it has a +2 oxidation number, okay, or charge. That's why these all look like this. Okay, it has a +2 oxidation number. Okay, and then we have phosphate, which is PO4 with a -3. Okay, now we can do our crossing. Just like that, and we are going to get, I only have 10 seconds to do this, come on. And we are going to get Mg4 3.